Hi, this is Jalal Ali and I want to cover in this presentation SparkX GraphX and GraphFrame API. In this presentation you will see here that my goal is to analyze the graph data using Spark GraphX and GraphFrame API. I will use NFL 2017 data results, and also I will use D3 to display the NFL power ranking and communities using GraphX and Graph API APIs. In this demo, I will be using Databricks community free edition to test GraphX using Scala and GraphFrame API using Python. At a high level, the pros and cons of this project: that GraphX has limitations. It only support RDD, it works in Scala, and only support long type vertices. No new enhancements since 2014. The same group who created GraphX created GraphFrame in 2016, which supports data frame, work on Scala, Python, Java, and has vertices types. Also, it will have support graph queries. GraphFrame is not part of the GraphX module. It's not a module of part of of Spark. You have to install it independently, and you have to run it independently when you want to use it. So graphs are everywhere. When you go for the social media, top influencers, you try to identify top influencers. When you try to identify the web interfaces, and when you try to understand people who has common interests, who likes what, all these are graph data. So what is a graph? A graph is a set of vertices and edges. So you have, take an example, when we have airports and flights between the airports, the airport itself is a vertices, the connection between are the flights. So GraphX was developed in 2014 in UC Berkeley, and it's the only component that we have not covered in this class. And it's use RDD, based on the RDD, and has a collection of algorithms like page rank, triangle counting, and connected components, and is a very powerful tool. And this is the landscape of GraphX API. You can measure for each vertices the n degrees, how many nodes coming in, how many nodes coming out, how many edges coming out from the vertices, the page rank. You can do a label propagation to identify communities, and you can do shortest path between vertices. You can do triangle count to see how many triangles each node is, the vertex is part of the number of triangles, that to tell you the importance of the triangles. As I said, the GraphFrame is a data frame based graphs developed in 2016 to address the limitations of GraphX. And as you see the comparison between GraphFrames and GraphX, data frames GraphFrames support data frames, GraphX only supports RDS. GraphFrames run on Python, Java, Scala, and it supports queries and algorithms together. It supports all types of GraphX only support long. GraphFrame is a Spark package. It's not included in the Spark release. You need to download it and pass it as a package parameter when you call PySpark. So what we did in order to show the API and demonstrate the API, I used NFL results of 2017, the first 13 weeks, and to present the data as a graph. Each team represents a vertices, and each relation between two teams in a game as won or lost is an edge. So when team A lost to team B, you will see an arrow coming out from team A to team B, and that will help us when we try to do all analysis on the team importance. With this, I want to go back and start showing you the demo and the data, how the demo of the data I have. First, I'm using Databricks. Databricks is a very powerful tool. The first step you have to do when you start running a project in Databricks is you need to create a cluster. And the clusters in Databricks are where you have your Spark running, and it's very easy step. All what you need, hit create, put the cluster name, and you define which Spark version you're running, which Scala version you're running, and that's it. I already have a cluster created, so let's go ahead and start and look on the project that I'm having here, the GraphX NFL. I'm running GraphX NFL on Scala because GraphX does not support Python. The first step is for me is to load the data from the NFL data here, which I store it already on the Databricks. And then for me, I start identifying the teams by looking for the union between the losers and the winners. And once I create the users here. For me, next I can look at this data, analyze it to see who are the ranks, the winners, the losers of the week 13. To create the graph, what you need to do first, create the edges and the team vertices as RDD and the edges as RDD. Once you create both of them as RDD, you can create the graph. Once you have the graph, you can do all the analysis you want to go from there. And to see here what analysis we have here, for example, let's take an example in degrees. What in degrees will look for me for each vertices, how many edges is coming from different vertices to this vertices. How many edges has this vertices as the destination. And when I run this and sort it by the number of in degrees, here's what we're getting here. We're getting an RDD. When we plot the RDD, we have New England Patriots has 10 in degrees, which is 10 wins. So this is showing us the wins for each teams. The top 4 teams are Patriots, Eagles, Vikings, and Steelers. And if you run the out degrees, you know the number of losses happen. So we can run the top 10 of them. We see that Browns, they have 12 losses. San Francisco, they have 10 losses. Giants, they have 10 losses, etc. So this is the out degrees. Because remember, as what we did from our side, our chart is the following, is team A point to team B. So the out degrees is the number of losses, in degrees are the number of wins. Next, what we do here, we do PageRank. PageRank is an algorithm that developed by creators of Google, and it's to find the importance of the web pages, and for them they look for the page that has most reference as an important page. Running the PageRank, what we see here, we see that the PageRank showing us the Steelers are top, New England as number 6. Go to the graph frames. First, before you start the graph frames, the most important thing, because again, remember that graph frame is not part of Spark. It's a library. You have to install it. So to install a graph frame in Databricks is a simple step. You go here to the work, you do the create, you create a library. Then here you search for the library here, a graph frame, and then you install it after that. So going back to our program here, the graph frame we have. The graph frame, you can run it in Python. Everything is data frame. It's simple and straightforward. So we can look the same analysis we did in the previous one, and this is how you create the frame. First of all, I have a union of the losers and winners. I have a edges as a data frame, and then after that I just go and create a frame, graph frame. I import from graph frames, which is not part of the Spark. I import it there, and then once the frame is created, you can do the same analysis as the in degrees, what we did in previous in the GraphX. In the out degrees, you have also same thing analysis. You see who are the top losers, and here we have the top winners. We have it here. And then you can do additional analysis that is not available on GraphX. Triangle count is an interesting API function in a graph. It counts for you how many triangles are formed with the same team here. And once you look there in the triangle counts, what you see here is surprisingly, like Arizona has 17, Cardinals have 17, Patriots here at the end of this one, they have 34. And because that means that Patriots are playing with more diversified team that has more interaction with other teams compared to what we have in Arizona. This is an insight that I was surprised about it, that I was not you don't see it directly here in the data, but when you see here, you see it here in this one here. Label propagation is also an interesting algorithm. It will tell you the communities that are close to each other. So when we run the label propagation, you will see later the label propagation here result. Let me go jump to the label propagation results here. In the label propagation here, you will see the teams who are almost belong to the same division and same conference. They are automatically, the algorithm identify them are as a group together. Teams who are in the same conference and the others are also automatic. So you see that it divided us into three different categories. And once that's the label propagation. Shortest path is another interesting algorithm here. In the shortest path algorithm here, you see that when I look for Dallas Cowboys, if I want to start from Dallas Cowboys winning a team, how many teams, what are the teams I want to go over to reach each one of them? So if we go here, for example, you see there is one of the team will be 4, is like Minnesota Vikings or the Green Bays. When I try to see the shortest path between Dallas Cowboys and Green Bays, if I use a 3 max length, I will not get any results, but if I use 4, I'll see which teams I can go to connect all the way to Green Bays. Label, we explained here. The page rank, same as what we explained the other one. It's the same thing here. It shows Pittsburgh Steelers are stronger than are number 1, New England as number 6. One of the powerful things of graph frames that's missing from GraphX is the queries. You can do graph queries. For example, if I want to find the teams who defeated each other, all what I have to do is say graph.find and use this motif notification, say A to B or B to A, and it will give me the results here saying here. So New York Jets beated Buffalo Bills and Buffalo Bills beated New York Jets, and so on. All these teams showing that they beat each other, defeated each other. Finally, I used in this analysis the D3 to show the graphs. When you look at the D3 here, for example, you can look at the size of the circle, tells you which are the important teams. The color of the circle show you the label of the teams and which labels of the teams. But if when I go down and see why Pittsburgh was better than better than New England, you will notice here that Pittsburgh here beated Kansas Chiefs beated Pittsburgh, and in New England lost to Kansas Chiefs, and Kansas Chiefs lost to Pittsburgh, and that's why we see Pittsburgh is powerful. Also, most of the teams who lost to Pittsburgh are more ranking than the teams who lost to New England, and that's why you have Pittsburgh higher ranking. With this is conclude my my analysis here, showing that in summary, what I'm saying, graph frame. If when I do graph analysis, I would recommend go with the graph frames. It's more mature, has more development, has a query algorithms. It's not only algorithms, has query, and it's better. It support Python. It run with data frames. With this, thank you.